Hello, everyone. Welcome back to a new episode of Advent of Code. I just had a look at our little calendar here. I'm sure you guys probably noticed before, but I hadn't really looked. Or I don't know. Maybe it hasn't been easy to see the way I've been recording. Who knows? Anyway, we seem to be building a little sleigh here, and we've finished off the basic hat. So next, there should be some new thing to build. I don't know. Let's find out what's going on in day 9. Marble Mania. You talk to the elves while you wait for your navigation system to initialize. To pass the time, they introduce you to their favorite marble game. The elves play this game by taking turns arranging the marbles in a circle according to very particular rules. The marbles are numbered starting with 0 and increasing by 1 until every marble has a number. First, the marble numbered 0 is placed in the circle. At this point, while it contains only a single marble, it is still a circle. The marble is both clockwise and counterclockwise from itself. This is designated the current marble. Then each elf takes a turn placing the lowest numbered remaining marble into the circle between the marbles that are 1 and 2 marbles clockwise of the current marble. Okay. However, if the marble that is about to be placed has a number which is a multiple of 23, something entirely different happens. First, the current player keeps the marble they would have placed, adding it to their score. In addition, the marble 7 marbles counterclockwise from the current marble is removed from the circle and also added to the current player's score. The marble located immediately clockwise of the marble that was removed becomes the new current marble. Okay. For example, suppose there are 9 players. After the marble with value 0 is placed in the middle, okay, so here's their example. The goal is to be the player with the highest score after the last marble is used up. Okay. Yep. So we have to run this little simulation for, I guess, like we just have a number, right? And what do we want to know? The winning elf's score. Oh, so I guess we get 2 inputs, right? Number of players and number of marbles. Let's just have a look at that. Yeah. So we have 486 elves playing marbles, and they have 70,000 marbles to play with. Okay. So it seems like the main question here is, like, what is the right data structure to use to store this kind of list-ish thing where you are accessing, not exactly in random order, right? But you're adding and removing stuff in the middle of the list. Well, not the list, in the middle of the data structure, right? And we're also sort of maintaining an index, a pointer into the array somewhere. It's, again, not a pointer, not an array, but whatever structure it is that we use, we'll be maintaining an index into it. Now, maybe that'll be somehow part of the data structure, as it would be if we were using, say, like, if we did this with a zipper of some kind, then you don't necessarily exactly need a discrete pointer. It can be just like sort of implicitly the place where you're focused, but I don't know. So the thing that what are the operations that we need on this? We need, well, random. Okay, so like I assume that data.sequence is the thing to use here. Which is Haskell's famous finger tree implementation, and like most of their languages just don't have a finger tree because they don't really need one. It's a finger tree is an immutable. I won't even quite say it's a list-like thing, but it's a way to get logarithmic performance on pretty much every operation you might want to do. Insertion or removal from anywhere in the list, concatenation of two finger trees, it's all like in principle logarithmic time. So we can do all of these operations pretty quickly, and we can just separately maintain an index, which is like where the current thing is. So what happened? In addition, so you remove. They don't place the marble they would have placed, and they score it, and then they move like 7 marbles counterclockwise. And remove that, and then 1 clockwise of that becomes the new one. Okay. So we'll be doing some modular arithmetic, of course, and we'll be working with data sequence. So let's look up the docs for Haskell data sequence. So seq is a finite sequence of values of type A. It has like all the stuff you would expect. Okay, and then we'll just have this handy. But I mostly needed to know what library it's in, and it turns out it's containers. So like kind of the best library in the universe apparently. It just has everything you might ever want. And do we need anything else? I don't think so. I mean, I guess if we wanted to, we could use a state monad or something, right? But I don't think that's particularly necessary. It should be pretty easy to just write a loop, a recursive function that does this, that does this loop. So what do we need? We need import data qualified data.sequence as s, and I don't know, maybe we'll want some other stuff, who knows. And then we need, well, let's just have a type. Well, okay, here's an easy one. Data I guess we could use regex applicative to parse the input, but it just like it hardly seems necessary, doesn't it? Yeah. So let's have a data type that's like problem, which just is a problem of num players and num marbles, both ints. This is the type that we're going to read from standard in and like use this to as our input, right? Well, actually, you know what? We can just call this input. That's a way better name, and we therefore don't have to change any of our type, this stuff, right? This stuff here. And parse is no, fine. We'll just do it simply. Parse of s equals let w's equal words of head of lines of s. Oh god, I never figured out how to turn that off. In input applied to s1 and s. Can I just do this? Is that going to work? This is a little bit funny, but And what word index is this? Oh, word 0. 1, 2, 3, 4, 5, 6. Yeah. Oh, W's not S. 0. Okay. So there you go. That's not a correct implementation, obviously, but I just wanted to... Yeah, so we got 486. And actually, like, let me just double check that we get this part as well. What a miracle. You guys might not notice the trickery that I have performed. This is absolutely not a good way to do this, but notice we took the line and we got the first line and we called words on it, and that gave us a list of, you know, it split on space and gave us a list of all the results. And then we called map read. This is the trick. This should not be allowed. We said take each of those words and please read it and put it into a list. And what type is it reading as? Well, since we're taking that word and passing elements from it to the input, those things must be ints. So read is reading each word in the line and converting them to ints. But there's only 2 words where that works, right? The first one and this one here, which is like number 6, number 0 and number 6. But laziness takes care of it. I never actually look at any of the others, and so the reading never gets done. It just stores a little note in element 1 saying, well, he said I should read this, and if he ever asks me what the value is, I'll read it. But it doesn't happen. So, okay, cheating, very much cheating, but good enough for me. Now I don't have to write a parser. It is a joy to write parsers in Haskell, but in this, these are just so simple that, like, why bother, right? Okay, so now I wonder, like, what's part 2 going to be about? How much can we factor out and, like, how much are we going to reuse and how much do we just sort of want to put inside of part 1 and forget about it? I think one thing we want is, you know what? Let's, I wasn't sure if I should do this or not. Define clockwise and counterclockwise. It sort of seems pointless. Like, wouldn't you rather just use positive and negative numbers? But I kind of like this as, you know, meaning we can have just one part of our program that knows about, like, how we're internally mapping, like, which way to go. Because it's sort of arbitrary. Should clockwise be a negative or should it be positive? I could pick either one and write my program and it would be fine. So what I'm going to do is make that decision once in one place and then not depend on it anywhere else except for that one place. So then we'll just define a little function here that's move. Delta is wrong. Let's say dir is a function from direction to int, and that int will be either 0 or 1. 0, -1 or 1. So we'll just say clockwise is 1, is -1. And now, none of the rest of my program should ever need to know about the difference, and we can just implement things as they were specified in the problem, either clockwise or counterclockwise. So, for example, we can write a function called move, which takes an int. Yeah, we'll want to write this as move 5 clockwise from x. So, yeah, we really should be careful. This shouldn't be an int. should be more careful. Data magnitude? Not data, new type. New type magnitude equals magnitude of int. So move takes a magnitude and a direction and an int and returns an int. In this way, I can't ever pass the wrong int to the wrong thing, which is a thing I do all the dang time if I don't make this little new type alias. So move of magnitude of m and dir of x equals x plus m times dir. Oh, we can't call this dir. D. Dir d. Now, this doesn't handle the modular part, but we'll just do that separately in part 1 or something. So what else do we need? We kind of need a data structure that represents the current state of the game. Where are the marbles? What marble number is coming up next? And what are the scores of all the players? So let's put that here. Data game is a game of scores, which is an int map of int, I guess. Kind of boring, but there you have it. Current player, which is an int. We'll call it rules, which is the input, so we know how many players and marbles there are total. I mean, I don't know. We could find out the number of players from looking in scores because we'll initialize everything to 0, but it's sort of nice to just have num players and num marbles around, so why not? And we need a marbles, or let's call it a circle, because that's what they call it in the thing. Circle is a sequence of marble, which I guess I should define something. Let's do it as a new type, why not? Maybe a type alias would be fine, but this shouldn't hurt. And current is a... Should I call this an offset? An index? Or just call it an int? Current index is an int. Maybe this will be okay. Data int map as m. Okay. So now part 1 is going to be a function that takes rules, constructs a game out of them, and then produces and then does a number of simulations on that game to produce a score. So what we really want is a function called tick, takes a game and returns a game, right? We'll just take one step. Let's call it turn, in fact. Turn of game I never know, like, when I have a record, whether it's a good idea to pattern match on it or just call accessors when I need them. Let's just try calling accessors when I need them and see how that turns out. Turn game. We also need like next marble or something. Next marble is a marble. Actually, I shouldn't do that. I should have like a bag, which is a list of marble. All the marbles remaining to play. And then I'll just know when the game's over because the bag will be empty. Is there anything else I should handle in a more... in a better way? In principle, I don't need to know the current player because that's just going to be like the index of the current marble mod the number of players. So maybe I can just get rid of this and that'll be fine. Okay. So turn of a game is where null... gosh, already it's like I should just be pattern matching. Game scores, oops, no comma, offset, rules. Yeah, I don't know. Naming all these types sucked. In fact, like, I don't know. We'll see. Bag, circle, Kirkle, the old Kirkle. Where null bag equals... No, this should never happen. We shouldn't be given a null game. Part 1's job will be to check that never happened. When it gets back a null marble bag, it'll just say, okay, I found the answer. It won't call turn again. So what exactly do we do? I guess the first thing is to say where MMs. We're going to assume there's always one marble, right? So where marble of M, where M mod 23 equals 0 equals score. So we'll have some, something in a where clause that we score with. Otherwise equal place. And we'll just put these both in a where clause here, where score equals something. Let's see. We will build a new game, and the scores will be m dot update. How do we update, delete, adjust? Yeah, adjust should be fine. Wait, why does it say key? Oh, key is a type alias, I remember. Okay. M dot adjust takes a function first, so plus current, which we'll have to look up in a minute here, but we'll just assume it exists. Or no, we are adding current and M. Both of them. And it wants a key, which is... Right, the current player is equal to M mod num player's input. And now I put in the M, right? The map? Yes. Scores. That's the new score we want. The offset is tricky, right? Oh, not input, but rules. So we should take, I mean, the current offset moves, we move 7 clockwise, counterclockwise or clockwise? Counterclockwise. So that's move magnitude 7 counterclockwise from offset mod okay. Oh yes, you didn't see that. It's okay. We're back to the docs already. I'll show you in a second what I typed. It wasn't very interesting. You heard me say it all out loud. How do I look up its indexing? What's the size? Like, finite sequences. All these patterns are very lovely, I'm sure. Length. Okay. Well, that's easy enough. -1, I think, because we are, but we're going to remove a thing from it soon. Okay, this actually, we need to be more careful with this. So let's just say, I don't know, undefined or something here, and define another new thing, which is to remove equals. Well, yeah, that's the index to remove. Yeah. And so it's a little tricky here because we want to, oh, what, hang on, Haskell, could you, what is -1 mod 5? It's -1. Yeah, that's not really what I want. I wish it would be 4. Okay. Oops. So what I will do, let's just define another thing here. size equal s dot length of circle. And here we'll say mod size, or mod size, but we'll actually, wait, is this right? We move 7 counterclockwise from offset and take that mod size, which is fine, except I want to first add a size. That way, I'll never have a negative number, and it's sort of going to be equivalent after we take this mod. Why are you upset? Error parsing. Yeah, okay. Well, these parentheses are not necessary. Move magnitude 7 clockwise offset plus size, and then take that mod size. That makes sense. So scores, I took this thing called current, right? So let's say current equals s dot, how do I look up a thing in a views? I don't really want a view. I just want to look up a thing. Look up the element of the specified condition starting from 0. So unlike index, this can be retrieve. Wait, what's index? Ah, this cheats. Yeah, it fails with an error, so I want to cheat. Okay, s.index of circle at to remove. Unmarble of this. This will give me the int that was wrapped up in that marble. We look up in the sequence the position we want to remove, and we remove it. Okay. The new offset is going to be let's see. After we have removed an item, which one becomes the new one? Immediately clockwise of that. Okay. So I kind of think this like operation here is a thing I'm doing kind of a lot, right? Or at least this. But then again, like, what was I supposed to do? So what I kind of want here is to take to remove and then move that. But I want to do it modulo a different size. So it's not exactly a lot I can do. Move magnitude 1 clockwise from to remove. Why will you not go there? Because I have open parents, I see. And plus new size mod new size. Okay, we're getting there. We're filling out more fields. This is the easy one, too. That kind of, I don't know. This is not going super well, this day's work, I think. We'll just obviously continue passing the rules. Leave those alone, right? They're never going to change. Yep. Honestly, we probably shouldn't have passed them in, but whatever. We'll return M's, the remaining marbles. And the new circle is going to be exciting, right? Well, actually, it's not that bad. We just... Where's sequence? Here it is. Deconstruction, queries, views, not exactly what I want. How do I just... I know you can, like... Okay, drop. Drop and take are how you delete, like... Yeah, okay, so split at... So I want to split at one before the element... No. I have to... Oh, wait. There's delete at. Why did I somehow miss that? I just want delete at. Right. So I have a marble index, which is always guaranteed to be in the range 0 to size -1. And I want to delete that element. Easy. Okay. M.delete at to remove of circle. Not M, but S. So why are you upset with score? I feel like that should have been okay. It sure wants a lot more arguments, huh? Why? Score is applied to too few arguments. Oh, this all needs to be in parens. There we go. There's no, like, implicit grouping based on new lines. Sure. And honestly, like, all this stuff here should really be in its own where clause, because this is all specific only to the scoring operation. Place equals, and now we can write the rules for how to place a new marble, which should be blessedly simple, right? Let me just double check the rules for what's supposed to happen. So we simply take our current position and up here is what we're looking for. Lowest numbered remaining marble that are 1 and 2 clockwise. So what does that mean exactly? That are 1 and 2 clockwise. Let's look at their example. So clockwise is to the right. So here, of course, it goes clockwise of it. That's fine. How? I guess we... Why does this end up clockwise instead of counterclockwise from 0? I guess it doesn't matter. They're the same, right? Well, not really. Yeah, it does. It's the same. Because when 1 is the current marble, no matter which direction you look, you'll see that 0 is there, right? And if 0 is clockwise of 1, you know, great, fine. If it's counterclockwise, fine, who cares? What's important is that we're looking at 1, and we could view this 1 as being over here, and it would all be exactly the same, I think. Not sure. So between 1 and 2 clockwise. Circles are the worst. It's just so hard to keep, like, visualized. All right, let's look at a more, like, larger example, like, you know, here or some things where I don't have to worry about the boundary conditions where the circle's almost empty. Here, we take our current position, we move 1 to the right, and then we insert to the right of that, to the clockwise position of that. So what are the insertion operators here? Iterative construction, maybe? No. We can take a view, which I don't exactly want. Scan, take while, no, 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 no. Indexing, okay. Is there like an insert at or something? Yes. So here's where I might actually like leak my knowledge about which direction is clockwise and which is counterclockwise, right? I said I wouldn't ever care, but I kind of have to. Like, I'm going to take the current position, and I'm going to move... I guess, no, I just move 2 clockwise from there, right? And then I insert the marble. Is that correct? So say we start here. Our index is therefore 1. We move 2 clockwise, making our index 3. And then we insert the next marble at index 3. 0, 1, 2, 3. Shifting the rest over. That's fine. What about when we go over... when we wrap around the edge of the sequence? It feels a little tricky, but I think it's actually fine. Here our index is 1. We move 2 clockwise in this same, like... and let's say we stay mod 3, which I think should be fine. We would move from 1 to 3, and then we'd go mod 3, so our index would become 0. We would then insert here a 3, which is different from what they've drawn, but semantically the same. You can't tell the difference because we're treating this like a circle. So I think that that's all fine, and actually, like, there's really not much to it in the add case. Place equals game of scores, and the current offset is new offset. And we'll put that in a where clause, where new offset equals move yeah, the parents there are fine. Magnitude 2 in the clockwise direction from offset plus size. See, I don't know whether moving clockwise is could possibly lead me to a negative number. I'm not even bothering to remember that the counterclockwise direction is -1. I'm just adding size because, like, it's safe. Why not? Oh, actually, if the circle size is small enough, like if the circle size is currently 1 and our index is 0, moving -2 could leave us at -1, even though we add size. So let's just add like 5 times size. Guaranteed. Never going to be too small now. Mod size. And we'll just, size is reused between these branches, so let's put it here. Fine, that's our new offset, and the rules remain the same. The marbles, we're going to advance by 1 still. M's, and now the circle is a little bit more interesting, but not that interesting. It's just going to be S insert at new offset. Hang on, what are the order of arguments to this? It does take the int first, and then it takes the item to add, and then it takes the sequence. The item is going to be marble of M, and then the circle. Incredibly, this type checks. Okay, well, is it correct? I don't have a lot of confidence in that. It might be. I guess we'll try running it. It's a number. I mean, okay. I'm okay with typing a number in and hoping it's right. Too low. Okay, good. So something interesting has happened. We've gotten an answer wrong. Wait. I didn't do the other part. Okay, of course. We're just not done. Part 1 is just the number of marbles. Okay, so what we really want is, say, part 1 of G, where null bag of G equals so null is the function that tests for emptiness of a list, or a foldable in general. So when the bag is empty, don't call turn again. And we compute the final score. So what is it that we're being asked to compute? The score of the winner. So that's easy. Hang on. Maximum of m.lms of we called it scores of G. G doesn't take an input. It takes, yeah, okay. So part 1 takes just an input. Rules equals go of, I'll be right with you. My music playlist ran out. Well, I don't even know what I was listening to. Let's listen to some chiptunes. Okay. Okay, I'm back. Get that mouse pointer out of there. So we need to construct an initial game. Well, this is easy. There you go. And we'll just define a... so this is now going to be go, where go G equals... and we'll define a little function here called initial game. Initial game of rules equals it is a game where the scores is are, I guess, game of I assume there's some sort of constructed via repetition thingy here. Construction from unordered lists. Yeah, I mean, I'll just use replicate from list. Okay. Well, I guess not replicate, right? It's zip. I'm gonna zip it with something. Yeah. Game of m dot from list and zip with 0 applied to the num players of the rules. Oh, initial game needs a type. Is a function from input to game. And it needs some more things. What else is in a game? Current index is just 0. That's very simple. And I'm going to actually insert marble 0 in at the beginning of the game so that we can maintain the invariant that the marble circle is never empty, because that's a bit weird to deal with. And we just pass the rules in. And our bag is map marble of 1 up to num. Okay, let's start it, because num marbles would be too high, right? So we'll just map rules. So, right, because num marbles of rules would be too high. If we said from 1 up to the number of marbles, then we would have a marble numbered 1 too high. And so instead I'm just going from 0 to number of marbles, which is the right number, and then I'm just calling, oops, not pred, I want the opposite of that. The successor, which is like, this is the function that adds 1. But it's more general, works for anything enumerable. For ints, it adds 1. And finally, we need the circle, which is just s dot singleton of marble of 0. Okay, why is this all broken? I mean, okay, so first of all, I could have written it like this, but I assume this has the same problem. Yeah. Game is applied to 6 arguments, but its type has only 5. I forgot parentheses here. Okay, and what's wrong with this? Yes, sure. What I actually wanted was this is not quite right. Why is rules? Why am I applying this to rules? Yeah, I don't want that. I want this. So, oh, but this is backward, right? I want the 0 to be yeah. So I need the keys to vary, but the values to be the same. So we zip a sequence of integers with an infinite list of zeros, and that's our initial scores. Okay. I could try printing the rules before I run the program and see to make sure I print the initial game and that it comes out right, but I'd have to add a lot of deriving shows, and I think I have it right, so I'm not going to. Again, this is going to be another one that'll be a bit tough to debug if I get something wrong. Oh well. And otherwise, there were more things, more marbles to add. And so I'll just go of turn G, right? That seems okay. It still compiles. That took a lot longer, and we got a bigger number. Okay. What do you think, Advent of Code? How's this number? That's too high. Okay. Well, I mean, let's test it on a much smaller input. They gave us some smaller inputs, right? Part 1 of input of number of players is 10. Oh, wait a minute. Last marble is worth. They're not telling us how many marbles to use, but what the last one is. So our initial game setup is wrong. We shouldn't have mapped successor over this. We should have just said 1 up to this. And so now... Well, we shouldn't call this num marbles then, right? Last marble. Last marble of rules. Incredibly, we never use that anywhere else. Okay. I mean, we'll run it again and get a different number. It's the same number. What? We should have gotten something different from that change, shouldn't we? So, okay, how many marbles are actually... Yeah, this has got to be correct, given what we're supposed to have done. Okay, so... But all right, what I was about to do was test it on one of their test inputs, right? So what is part 1 of input of the number of players they give us is 10, and the last marble is 1618. 8807. So that is an incorrect answer. It should have been 8317 according to their test input. I'd like to visualize where things are going wrong by like printing out a game in the exact same way that they have in this example here. Each player... Wait. So the marble with 0 is placed in the middle. Does that count as someone's turn? I guess it doesn't matter, does it? Because I don't know. I don't need to know which elf got that score. But okay, so first 0 is placed in the middle, and that's not anyone's turn. The marble is just placed becomes the current marble. Okay. And when do they actually remove a marble? Here, right? So they don't actually print that anything interesting has happened. So I'd like to have a function that prints out a state and then have part one print out each state that it reaches, and then I can see where it's going wrong. So let's write that, I guess. Display is a function from game to string. Display, and I won't bother printing whose turn it is because that doesn't matter, I think. I really just want to look at the marbles, right? Display G equals unwords, I guess, of something. Let's zip with draw and 0 on the, what is the type of zip with, by the way? It only works on lists. I guess that makes a little sense. It shouldn't work on anything foldable. So s.toList of the circle of G. Unwords, zip with draw, okay, where draw of I and marble of M, where I is equal to cur equals this is what a lame way to draw this, but okay. Map show, I guess. On marble as well. So here we're actually just gonna take a string S, and otherwise it's just S. S.toList does not exist. Should I just use the one in foldable or in data.foldable or something? Fold map with index would give us back a seek, but I don't really want that. Oh, I need to like take a view of it. I want like a view L or something. There's from list, very funny. What is it? Wait, what, cycle? I saw something that said cycle in here. Should I have been using this all along somehow? Kukl? No, I don't need that. So we can take a view of the left end of a sequence. Yeah, but that just like lets us treat it as a cons, basically, which is not really what I want. I mean, it's foldable, right? So I should just use the one from data foldable? Yeah. Okay. I feel like that should be done by more libraries. I don't know, like maps have export their own like toLists, and like why? I don't know. Import data.foldable toList. unwords is in data list? Where the hell is unwords? Haskell unwords, please. Data char? Data string. No, it is. It's in data list and data string? What? No, I said unwords. It's in... where? Data.old list. Hilarious. I thought that was just like in base. I mean, it is. It's in. It says prelude. Oh, it's lowercase. Okay. Oh, I forgot to define the cur. Cur equals current index of G. Okay, so let's now try, this all compiles. So let us display the initial, hang on. Display the initial game of this. Great. Now let's write turn of this. Actually, this won't work because turn is local to... No, it's fine. Great. Whoops. Here's how I get to the window I wanted. Okay. So let's start, in fact, with the one that they visualized for us here. Suppose there are 9 players, right? So give me, in fact, an input of 9 and a bunch of marbles. Sure, I mean, I guess that's the same. And so this is already wrong. So where does it first go wrong? So like, let's just say I take a single turn. I have 1 and then 0, which looks different from what they've drawn, but as I described, I think it's okay. 2 marbles, like their order is sort of arbitrary. As long as you have the right one highlighted, you're okay, I think. And if I now say turn of this, I get a 2. So this still looks fine, because to the right of 2 is 1, and to the right of 1 is 0, and like this is still all okay. One more turn though, 2, 1, and then 3. That looks right, yeah? See, like, we have a 2 and then 1, a highlighted 3, and then a 0. Again, they're in a different order, but it shouldn't matter. Here our 4 is highlighted, then we have 2, 1, 3, and then 0. I think this is actually all correct. It looked wrong, but that's just because... yeah, this is all going fine. So our trick is that we're doing scoring turns incorrectly, I think. So this should place 8 in between 0 and 4, which it did, and it highlighted the 8. Okay, so these are all going fine. So let's take a large number of turns. Display iterate turn on this. After 0 turns. Okay. So when the... How do we score? So when the marble to be placed has a number which is a multiple of 23. Okay. So I need to, after iterating to 0, okay, so if we do 22, we should be about to place, oh, whoops, I forgot. What in the world have I pasted here? This is a mess. Iterate turn 22. So this should be right before the scoring happens. We have 16. I can't show you guys both screens at once, sorry, but I need to line these up. So right before we score, we've just placed 22. The highlighted marble is 22. After that, we have 11, 1, 12, 6, 13, 3, 14, 7, 15, 0. 16, 8, 17, 4, 18. Oh, yeah, that's right. Then 9, 19, 2, 20, 10, 21, 5. Okay, so this is the correct sequence right before the scoring turn happens. Why does it like keep what? When I say show me the previous thing, it like prints this ridiculous, like this is not an input I ever made, I don't think. So what happens after we score? We have 16, 8, 17, 4, 18. Ah, I have the wrong current marble. 19 should have become the current marble, not 2. Otherwise, everything looks fine. The marble that was scored was number 9, right? 18, and then the 9 that was here is gone now, so we pocketed that. And we also pocketed number 23. So I think that the score computed was correct. We just put this in the wrong place. So that we have a score here. So we moved one clockwise from the element we were about to remove. And took it mod new size. I mean, okay, so what do the rules have to say about what should happen here? First, they keep the marble they would have placed, and they save it. Then we go counterclockwise 7 times. We got there, yeah. We remove it and also add it. We did all that. Ah, I shouldn't actually move clockwise at all. Yeah, this is where the fact that like clockwise is positive is sort of implicitly needed, because removing that marble already moved our pointer clockwise in a way. Okay. So I'll just say this. We need to make sure that it's still within the right modular or whatever. So we wrap it mod new size, right? It might have fallen off the end of the list. If we removed the very last item, then our pointer is now past the end of the array. And so we need to take it mod new size. So having done this, why does it keep giving me this ridiculous thing? So now, 16, let me just double check that that's correct. 18, 19, yeah, that looks fine. Okay, and if we, $10? No, what I want is like part 1, there we go. This produces 8317. That number sounds very familiar, and I hope it was correct. Look at that, 8317. Let's do the biggest test case next. No messing around with baby inputs. Input 30 and 5807 is 37305. Okay, this is great. It works now for all of their test inputs. So let's put this baby in. That's the right answer. Okay. Amused by the speed of your answer, the elves are curious. What would be the new winning elf score if the last marble were 100 times larger? Interesting. I mean, this doesn't take an outrageous amount of time. Yeah, it'll take 2 minutes, but we're not doing anything that's like going to be quadratic. We're iterating each step, and it's like fine. We're not having to like. This is to catch people who are using an array and just inserting in the middle of it because it's cheap enough. So actually, let's git add day 9 part 1 finally, and part 2 of rules equals just part 1 of input input players marbles is part 1 input of players and 100 times. I shouldn't call it marble. I should call it last marble. Okay, so this will take a couple minutes, but I don't think we have anything that will scale linearly with the size of the input, or super linearly. Now, here's the thing, there must be a more efficient solution. Topaz, the creator of Advent of Code, guarantees that... Ooh, also, we're not going to overflow int, are we? No way. I mean, we could use an integer if we had to, but I don't think it's a problem. Anyway, he guarantees that there is a solution that on 10-year-old hardware will run in 15 seconds for every problem, so that you can participate even if you can't afford the fanciest new computers, right? So anything that takes 2 minutes means that you kind of missed an opportunity to do something faster. And so what could that be? What could we have done better? Oh, also, it finished. I was about to say, let's interrupt this and compile it instead of interpret it. Maybe that's part of the problem. This actually might have overflowed int. 2.9 billion? Max bound of int? Oh, no, it's 64 bits. Okay, or about. That's the right answer. Okay. Cool. So by choosing an appropriate data structure, we had no trouble with part 2, which just basically said, was your solution reasonably fast? And it wasn't great. It could have been faster. But I don't immediately see how, right? What we did just felt pretty normal. There's probably something you can do where you don't actually have to model the whole game and you can apply some formula or something, but I don't know. I mean, we were doing logarithmic work several times, right? And maybe you could have done constant work somehow if you understood the rules a bit better. But I'm perfectly happy with this. Is there anything else we could really improve? I really don't like this. Implicit, right? We implicitly need to know we're cheating here. by knowing that clockwise is the larger direction. I'm not sure exactly what the right way to fix this would be. Yeah, because we implicitly move clockwise here. I mean, I guess the right answer would be to use a zipper or something where we don't actually track integers at all, but just have a way to move left and a way to move right and a place where we currently are and a remove operation. But even then, if we removed... Well, I guess if you had a zipper, you'd have a direction that's clockwise and a direction that's counterclockwise. And when you remove, you would point yourself in that direction. I guess it would be okay. But then you'd have to know either the left side of the list is clockwise or the right side is clockwise. So it's like kind of seems about the same. I don't know. I'm not going to worry about it. Day 9, part 2. Nice and easy. All right. Well, let's go look at the calendar. There seems to be some new feature developing here for day 10. Day 9 just sort of finished the sleigh, basically. Okay, sure. Who knows? We'll find out tomorrow, probably. Thanks for watching, and I'll see you next time.